So our next speaker, he's a professional swimmer and he's a professional coach as well. So I would like to welcome Athar.
So our next speaker, he brought a ThinkPad in a world full of Macs for this talks. That's something different. We're also going to talk hardware at a free and open source software conference. But yeah, pun intended, but it's not hardware. So Atharva will be talking more about how you can use free and open source software to help makers make it easier for them to create hardware. So he has built a software called KeyCAD, which enables hardware designers and makers to kind of like make their own hardware. So I invite Atharva to talk more about what he has built and share his exciting journey.
Yeah, so please give a huge round of applause for Athar, who's going to talk about create hardware through open source ecosystem.
Can you hear me? Hi. So, hi, my name is Atharva Upadhye. I am principal engineer at Innominds. Today we are going to talk about create hardware through open source ecosystem. I have co-author Sri Kumar. He is not here. He's watching live. So let's get into it. What we do, we are a part of Innominds Connected Devices Group. We make custom electronic products. What I meant by custom electronic products is for the enterprise applications like phones, tablets, vehicle tracking systems. You can see there are a couple of products we have shown. On the left-hand side, this is the world's first DIY Android smartphone we have made. Then there is a smartwatch, which is an authenticator device we have used. And there is a passport verification device we have done for a Japanese customer. Yeah, it's kind of our product portfolio. Now, how did I end up here? I have designed electronic products for 10 years now. Earlier, I worked at Intel, where we made microprocessor boards. After coming to Innominds, we have Qualcomm platforms, which we have worked on. Innominds is a Qualcomm licensing company, so we have access to their reference design, and then we take it from there for customers. Now, after some years at Innominds, I get an opportunity to work on R&D project, which we actually turned into product later. So because of this in-house project, I got opportunity to explore open source tools which are required in a hardware ecosystem. Okay, so let's talk about that a little bit. So how many of you have learned electronics earlier in the engineering, any background? So very less, right? So I'm sorry for that. So, okay, so I'm going to brief a little bit about how hardware design works, right? What are the steps? So for all of us which don't know anything about hardware design, let's follow the analogy of constructing an apartment, correct? So now you must have seen this, like drawing a circuit on the paper, right? This is my first step where I draw the circuit, LED circuit. There is a software for it in the corporate sense. So you can see this software is, there are two softwares which mainly corporate use, which is one is OrCAD and second is Altium. These are all proprietary tools, what I'm talking about. So this step is similar to now I'm building plan is putting on paper. I'm putting where a staircase goes, where the lift goes and everything, but in the software. Okay, there's the next step. So this step is a crucial one where we actually turned our design ideas to a reality, which is a printed circuit board. So as on the left-hand side, you can see there is a breadboard. Breadboard you must have seen in college. So I have a battery and then LED lights up. So if you take that breadboard to a customer and sell it, he won't actually buy it, right? So you have to make a product out of it. So on the right-hand side, as you can see, it's the same circuit has been drawn on the printed circuit board with a tool called, it's actually a Allegro tool. This is also a proprietary software. And there is one more, Altium. Okay. So till now, we have used two tools, different tools, and two different set of engineer capabilities to actually till now commit here. We still not have manufactured the design, right? Now we will go into the manufacturing it. So one part in the analogy, I missed it earlier, sorry. Now this is analogical to you going to the site, now marking the boundaries of it and putting it where I am going to put a hole, I am going to put a bars and everything, right, in the apartment sense. But still I have not started constructing it. So now this is my step of construction, where you can see the green color one is called as a printed circuit board. You must have seen in mobile phones, laptops. And then you can see my LED, you can see a resistor, you can see a battery holder, right? All this is called assembly of the PCB. Right? This is very similar to now building construction. I'm starting digging holes, I'm putting plumbing, I'm putting rods and everything, right? Now what is missing here is, now I cannot sell this PCB yet because I have to enclose it like the walls on your home, right? So now I am going to start a mechanical box design. So this is also one more tool which we use for mechanical box design. Industry mostly uses SolidWorks, CATIA kind of softwares. We will talk about open source on this parallel later. So this is still a proprietary software for SolidWorks and CATIA. So now, okay, right now we have used 3 different tools for 3 different expertise of engineers to make one PCB or one electronic product, right? So we will talk a little bit about why corporate uses, or my company or any other company uses the proprietary tools, right? So first and foremost point is reliability. Most of you guys I have understood that you're software engineers, but one thing is, like, if you make a mistake in the hardware, at least you are going to get costed $5,000, and it is going to set back your schedule by 5 weeks, because it takes at least 3 weeks to make a new product, okay? And 2 weeks to make your problem go away. So $5,000 plus 4 and 5 weeks, it's a costly venture, I would say. So that's why people like me also like to stick to what we know, proprietary tools, right? One more thing is time to market. So I work at a company where somebody comes at me and says that make a tablet or make a phone for me in under 1 year, right? So it's crazy to make a mobile phone under 1 year from scratch. So we actually rely a lot upon Qualcomm reference designs, right? Because we are a Qualcomm licensing company. So if you take a Qualcomm based designs and you want to build on top of it, these designs will be in a proprietary tool. So you don't have any wiggle room to go and check actually what is happening in the open source ecosystem if you actually stay in this business, right? Second thing is complex design capability. So just to give you an example of how complex your PCBs are, so if you take an iPhone and check the teardown videos on YouTube, so your iPhone PCB has 16 layers of it, okay? So just to give an example of it, it at least has 16-story building inside it, okay? So that's how complex design these are. And so that's why proprietary tools people stick to, because they have been there for 30 years, they have been highly tuned, you have all automated Python scripts running on it. I mean, the ecosystem has evolved around it. So now, also, one more thing is talent accessibility. Now, if you see last 20 years, engineers has picked up their tools. So as I said earlier, we counted 1, 2, 3, 3 tools required for electronic design. Now, all these 3 tools have different people who actually are expertise in it. So it has become a segmentation nowadays. So it's fairly available talent pools across all of these proprietary tools. So now I really ask myself, like, why somebody would go for open source tools, right? So this is the problem, right? So if you actually calculated all of this tool cost, you can buy InnovaCrista. So it's very, very costly venture just as upfront itself, because this is upfront cost. I'm not even saying that you have started doing the design. This is, you went into shop and you bought something and you still don't have anything. Now you have to go and find a talent who uses this tool. Then you have to manufacture these devices. And that's how there are, 2% of hardware companies and the rest of the software companies, right? So we actually also face the same problem for our in-house project, and we thought, like, what we can do to solve this. And then many of you would have been an enthusiast about open source system. I was not. I am a hardcore proprietary guy till last year. And then my boss basically pushed me into it because he said, look, its design is not complex. You can give it a try. And so that's how my journey started as a FOSS enthusiast. Okay, so now I came across this tool, which is called KeyCAD. You can pronounce it as KeyCAD or KeyCAD. Okay, this is a tool which was actually funded by CERN. It's a nuclear research institute from Europe, which actually did the Large Hadron Collider. So this same company actually funded this project. This tool is called Electronic Design Automation Tool, where you can actually do all the stuff which we talked about earlier, drawing schematics, which is drawing circuits on the paper, then actually putting a layout, and then So mechanical design, there is one more free open source tool which is called FreeCAD, but I'm not going to talk about it because I don't have much expertise there. So so 2 parts of the crucial electronic design which are shown here. The red color box basically shows that these 2 tools allow you to draw the circuits. Next green box, which are the 2 tools which are available under this KeyCAD, allows you to draw the layout, right? So this is the crucial part where now at free cost, you are able to actually draw the circuits, make them ready for manufacturing, right? One more thing is this tool is in now its 7th version. It's very stable. Now ecosystem is evolving around it. So there are a couple of direct advantages of using KeyCAD over proprietary tools, right? So one thing is full design flow available under one kit. What it means by is, if you actually understood what I said earlier, there are 3 different tools for proprietary. So there are 3 different companies who actually have 3 different tools which makes the electronic product. Now this tool has come up with at least make the 2 processes under one hat. So now with using this tool, you can at least make a PCB standalone with this tool. You don't need any other software, right? One more is exposure to full design flow. So what we have seen around, or what I have seen in 10 years is 90% of the engineers or 95% of the engineers, we actually don't use both the tools. So I would actually gladly admit that earlier, like 2 years back, I was the guy who only does schematic drawing or the drawing circuits. And PCB layout, I won't touch because it's beneath me, I used to say. So now, as soon as my boss pushed me into it and then I started understanding it, so the more control I got over the process, the more better I got as an engineer as well, right? And then that thing which was beneath me started actually liking it, and then I adopted it. Okay, so this is one of the advantages of that. It exposes you to the full design flow. Okay, let's look at one more. So you have to understand from the hardware point of view, we are very control freaks. So we need a control in each and every processes because, as we said, mistake, $5,000, right? So one of the key aspects of control is if you ask for a help, somebody should reply to you. So this has a very vibrant community. KeyCAD has a very vibrant community. If you actually post a question, you'll get a reply under like 1 day. I got under 1 hour. So this is very vibrant. So you can rest assured that you have a very good response coming from the community if you end up in a problem. This is one more direct advantage of KeyCAD is it's a unique advantage, I would say. No proprietary tools out there actually supports this. So now if your PCB is basically now ready to make for manufacturing, one thing you have to see is it actually okay? Does it look okay? Am I making any mistakes, right? Because one mistake, $5,000, right? So this tools give you 3D visualization of the components, how it looks like, and all that stuff, right? So this is one of the most big advantages of using KeyCAD. Apart from direct advantages, I would say there are some intangibles, right? So you won't see this happening in 6 months, but you will see this effect over the long term. And this also I guess, because we haven't seen it, but this is what I guess. So one thing is global community exposure. As soon as I started using KeyCAD, so before that I would say that, see, hardware guys don't share, okay? Because our design is our IP, okay? And I don't know, there is a lot of modularity in the hardware, but still we don't share. So what happened is when I started using KeyCAD, now I started looking at a community which shares the hardware design across. So most of if you see open source hardware projects are done in KeyCAD. So what happens is you get instant access to thousands of designs, which actually cuts down your time to market. Also, it cuts down it actually improves your efficiency, right? So these are the things I am also looking from the corporate point of view, right? Time to market is less, my efficiency is better. So this KeyCAD gives you that advantage, right? As soon as I started looking at KeyCAD, I was connected on Twitter and I saw people doing their own designs in different areas of expertise. I also started looking at where they make that design, right? In hardware, the most important part is where you make that design. So there is a lot of political debate, right? China, India, and all this. So where you make it is also very important in hardware. So that in KeyCAD, when you get exposed to, you understand where people are making it design, where they are making in China, they are making in Indonesia, how we are making it, right? Or what components they are using. Are they using China ecosystem products or Texas Instruments, like American ecosystem products? So these are the things you get exposed to when you actually start using open source KeyCAD tool. Yeah, one of the main factors. And the last one, the intangible, I would say is, it's a little bit emotional, right? Like resource become maker. We all are resources on the payroll, okay, at the end of the day. But there is a chance to actually turn it around, right? So what I saw in myself also, that when you are exposed to complete ecosystem or a complete design flow, what happens is you just don't talk about ideas. Now you start to realize it. Because you have open source tool. Now, what you have to make is just hardware, right? And that will cost you around 10,000 rupees just to prove your idea, right? So that's why after using a KeyCAD tool, I started looking at complete product, and I'll show you some pictures of what products I've done later. So this is one of the big advantages. Second thing in corporate is we follow what our colleagues do most of the time, okay? That's why there is one leader and all we are followers. So there is something called domino effect, you must have heard. So when I started using this tool, people started looking at my desk and started talking to me and asking like, what is this? Looks like a new tool, right? And then I tell them it's free. And then second thing I tell them is it's completely control, right? You can control whole design process. And third thing is it's free, okay? So all of these advantages now patch up on and saying that, okay, I'm gonna also try this tool once. So this started as my colleague also adopted, and then that colleague also started design. He ended up problems. So I have also blew the first board which I did with KeyCAD, but eventually I have gone better. So it will happen, but you will reach there. So now many people have asked like, okay, this is Gyan on the software side. Have you done anything out of it? So I would like to actually show you, this is the project. This is a product actually, right? So we have done in-house. So this is, we call Smart Terminal. You can see on the left-hand side, black box, and the right-hand side, black box, so small and big. So I would actually admit that, so left-hand side black box is actually made in proprietary tools, okay? And the right-hand side is something which we made in KeyCAD and using FreeCAD for the mechanical design. So we are also work in progress. We are reaching there to make that big black box also in open source tools. Little bit about the product. So from the vision point of view, so India has 25 crore children. We want to educate every one of them. We need digital classrooms, right? Right now, the way to make digital classroom is people keep buying laptops and tablets. We think so, we believe so, that is not a sustainable model. So we have come up with a product which turns your digital classroom. We actually try to make a classroom digital under 50% of the cost and with more than 50% of the efficiency. So little bit details, I will come back to that later. I have a small video. I don't see any audio for that. But so I could show you, you can see the blender. One guy is playing game. All this is happening on one laptop, okay? All 8 terminals, and we can actually make it to 16, okay? This is the application of what I earlier showed. One more application is you can see earlier 8 terminals. Now you can see 16 of them, all with a high resolution and 30 FPS. This actually is running on i3 desktop, which costs 30,000 rupees, okay? Linux, okay, that's the only software word I know. Okay, so it runs on Linux and Wayland, okay? So, yeah, that's it. I mean, thoughts of it on this is, now every resource in your company, right? I'm not call employee, it's a resource. So every resource in your company now starts to adopt open source tools, looks around ecosystem. Now he has the opportunity to make the ideas into reality. He starts to make their invention. So now we'll have the product economy. Yeah. So that's it from my side. Yeah. So these are some hobby projects I did, some earring, and then the right-hand side is your router UPS board. This is all made in KeyCAD, right? So you can, what I'm trying to say is you can do your hobby projects like earring for wife, okay, to the commercial projects for router UPS, okay? Thank you. So you can reach me at this. I'm around, you can catch me. Thank you.